The cosmos is within us. We are made up of star stuff. We are way for the universe to know itself. And that was a quote by the world-renowned scientist Carl Sagan, which I believe encapsulates my presentation for today. Today, I'll be presenting on the topic of the sciences, in which I will use the James Webb Space Telescope as my main example. Before we begin, here's a table of content. I'll first start off by introducing the articles I've chosen for this presentation. Then I'll move on to explaining what is the James Webb Space Telescope and explain what are some of its capabilities. Afterwards, I'll talk about some of its implications and end off the presentation with some of my concluding remarks. These are the articles I've chosen to base my presentation on. The first one is from the Smithsonian Magazine, and the second is from Space.com. So what is the James Webb Space Telescope, you might ask? Well, here are some context to begin with. The Hubble Space Telescope on the right was launched in April 24, 1919. As it nears its 32nd year of operation, Hubble has helped the scientific community broaden its knowledge. However, given the incomprehensible vastness of our universe, Hubble's abilities to catch light emitted by early stars and galaxies are limited. This is where James Webb Space Telescope comes into play. The size of a tennis court when fully deployed, the Space Telescope was set to become the biggest telescope ever to be launched into space. It will be the successor to Hubble, which is about the size of a school bus. The JWST consists of 18 hexagonal mirrors which will fold together to form a 6.5 meter wide mirror that will capture light from over 13.5 billion years ago. These are just some images captured by the Hubble Space Telescope. The image on the left are pillars of hydrogen and helium clouds in the early stages of a star formation. The left is a nebula, which is a dying star exploding outwards near the end of its life. When the James Webb Space Telescope is fully operational, it will be able to take more pictures at sharper resolutions even when the light capturing is very faint. The James Webb Space Telescope will attempt to capture light emitted by the first stars and galaxies from just 40 million years after the Big Bang. To further understand our universe's origin, it takes light from our sun 8 minutes to get to Earth. So whenever we are looking up at the sun, we're actually looking back 8 minutes in the past. In the same concept with our ever-expanding and vast universe, light from distant galaxies that were formed just after the Big Bang would have taken about 13 billion years to come back to Earth. This graphic shown here depicts the timeline and expansion of our universe. As seen, our universe is roughly 14 billion years old, and the first star started forming about 400 million years after the first Big Bang. The James Webb Space Telescope will be able to peer back into time to capture images of these first stars and galaxies, finally giving us real photographic images of what the early universe looks like. Other than peering back into time, the James Webb Space Telescope will have the ability to look and study black holes in much greater detail, detect possible chemical signatures indicative of life on other planets, as well as studying early stars and galaxies to further understand our origin. Speaking of detecting possible alien life forms, the James Webb Space Telescope has the ability to distinguish and detect chemical signatures on other planets. Some of the most important chemical signatures that the James Webb Space Telescope will be looking for are water, oxygen, and methane. The presence of these chemicals can either indicate whether the planet is habitable for life for us or it itself hosts life. So why is the James Webb Space Telescope so important, you might ask? Well, to put it simply, the telescope will help us understand fundamental and quite pressing questions many have longed an answer for. Additionally, we ask questions like, are there life out there? Are we truly alone in this ever-expanding universe? So to end off this presentation, here are some of the key takeaways. Firstly, the James Webb Space Telescope will have the ability to essentially travel back in time to capture images from 13 billion years ago. Next, the technology that this telescope will have will allow us to detect other possible life forms or habitable planets. Lastly, we will be able to detect and investigate stars and early galaxies and even black holes in much greater details to understand our origin. Thus, from what we have seen here, the sciences is an indispensable tool for us in the 21st century. With the falling mortality rate, unparalleled convenience brought about by the creation of the internet and planes, and finally, the launch of the James Webb Space Telescope, which has been in the making for over 20 years, I cannot wait to see the discoveries we'll make in the future. Thank you for your time.